Okay, pause and copy. Pause and copy. Okay, the column space of a matrix A is the span of the columns. Simple as that. A couple remarks here. It's a subspace of Rm. Okay, we know this because spans are automatically subspaces. And why is it M? Well, you have to take your matrix A, and it has M rows and N columns. So if you think of the first column, how many entries does it have? Well, it has M entries. Okay, now I want to convince you that the column space is the same as the range of this transformation here. Okay, so range by definition is the set of all images, everything of this form. Well, T of x is just the same as AX, right? So that gets me this equal sign. Now, when you perform this product, you get a linear combination of the columns of A. So where are we? The set of all linear combinations of the columns of A, that's exactly the span of this set of columns. And that is the column space. Okay, so a few steps there, but hopefully you can see that. Okay, let's try an exercise. So pause, copy, and try this out. Pause, copy, try. Okay, so what did I just say? The number here, the column space is a subspace of Rm, so it's going to be 3 here. K is 3. I'll remind you, this symbol here means subset. So the column space is a subspace, so it's automatically a subset of R3. So null, the null space is, well, how does one be a member of the null space? Well, AX has to be 0. So this product here has to make sense. So you imagine a vector here. How many entries does it have? Well, it's going to have 4 entries. So that's 4. So find a vector in the column space. So, column space is the span of these columns here. So easiest thing to do is just take the first column. Now, something in the null space, which is not 0, well, I'll go back to my vector here. I want A times this vector to be 0. So how can I guess an answer here? Well, I can see that if I stick a 1 here, then when I do the product AX, this 1 will always be multiplied by 0. Okay, then the rest of these things can just be zeros, and that'll make it work. 0, 0, 0, 1. Or you could put a 10, or 110, or 710, doesn't matter. Okay, what's next? Example, I believe. Okay, so here I'll do an example. Now, maybe pause and copy this. If the set here is given in this form, where I give you a typical element in the set, and then some conditions on the parameters. Well, what I can do is take this typical element and express it as, well, first I'll pull it apart, as we do so often in this course. And then I will write this as a matrix. Will I? No, no, no. No, I won't. I'll just stop here. So a typical element in my set here is in the span of these two vectors. And then from this calculation in blue, I can see that I can see that the A that I want here is exactly consisting of these vectors. Okay, to give you another justification. Okay, what is the column space of this matrix? Well, it's the set of all things of this form, right? The other way around, what is this set here? Well, from this equal sign, I see that it is exactly the set of everything of this form. Okay, so those two things are equal. Okay, I want you to pause and copy and try this one now. Pause, copy, try. Pause, copy, try. So I did something similar above. Second example. Hopefully you had a look at that. When I did this, here's the answer I got. So if you didn't have any luck there, it's okay, but just get my attention during class and we can sort that out.